Hello everyone, and welcome to Real Time with HKPCA and IPC Show 2016 here in Shenzhen, China. I'm Stephen Las Marias, and joining me today is John Ranieri, Business Development Manager for Rogers Corporation. John, thank you very much for joining us.
Thank you, Stephen.
All right. So first, John, can you please tell us briefly about Rogers, for those who may not be familiar with the company?
Sure. So Rogers is in general, a specialty material manufacturer. We're headquartered in the U.S. and we have significant global operations, both in the U.S., Europe, and in Asia. We focus on materials that are highly engineered.
Right.
And our division, which is called the Advanced Connectivity Solutions, or ACS division, focuses on printed circuit board materials for two different applications. One is RF and microwave, so antennas, amplifiers, and all of the components that go with RF. And then the other is thermal management materials for power electronic solutions.
Right. Okay. So I understand you've been showcasing some products here at the HKPCA show. Can you tell us more about them?
Yeah, sure. So we have a few new products that are focused on where the market is going for 4G, the end of 4G here, and kind of looking towards 5G for the wireless infrastructure market. And also, we're also showcasing our ML series for the power electronics market.
All right. Speaking of 4G, the development nowadays, the new technology is towards 5G. What do you think, or what are you seeing in that trend?
Yeah, so we're still trying to figure out what exactly 5G means for Rogers and for the industry in general. Certainly, we know that there's going to be a significantly increased demand for data, mobile data, that's driven by video. And in fact, that we expect there to be an 8x increase in the demand for data by 2020. And by 2020 also, there'll be 50% share will be smartphones and smart devices, including tablets, phablets, and smartphones. What this means for us is that there will be, of course, increased data rates, lower latency, but also there's going to be a different spectrum allocation. So we're going to see new frequencies that are allocated for wireless infrastructure. Above 20 gigahertz. And also, we expect the network density to continue to increase. So you're going to have macro stations, but then also small cells that are interwoven into the whole network. So those have their own requirements.
Having said that, how does that impact the material requirements when it comes to 5G?
Yeah, so I guess I'll split it into two categories. So the traditional frequency spectrum less than 6 gigahertz, we believe that antennas are going to need have UL requirements. We also think that for power amplifiers, we need materials that have a higher thermal conductivity to dissipate the heat because the power density is increasing. And finally, we think that there will be a need for higher impedance control. That means that we have to make materials that have very tightly controlled dielectric constant and very tightly controlled thickness. For greater than 20 gigahertz, we know that these materials have to be thin. They have to be very, very low loss, and in many cases, and we know from our experience in the automotive radar segment, that often a non-woven solution is preferred, so no woven glass in the material. And also because the conductor loss is a large portion of the loss at these frequencies, we know that we have to have smooth copper foil.
Definitely signal integrity is going to be a big issue, right?
Yes, absolutely.
So you earlier mentioned about your ML series of materials, and can you maybe talk about that, or is it going more suitable for application?
Yeah, so this is a little bit of a different area for us. So I mentioned the RF market previously, and of course Rogers has been involved with the RF market for many, many years. And now we're looking at a slightly different market, which is power electronics. And in power electronics, really, thermal management is extremely important. In fact, it's been said that really it is the engineering portion of power electronics that's a huge consideration. And so the traditional methods for thermal management have been to add heat sinks with thermal grease, potentially heat pipes in some designs, black paint, and in other designs, heat spreaders, and in extreme cases, active cooling. So that's you know, force conductive air or force convection air, and also liquid cooling.
Right.
And you know, the problem with those solutions is that they tend to be very expensive.
Yes.
They tend to be bulky, and then they tend to weigh quite a bit.
Sure.
So one innovative approach that we're trying to solve with our ML series of materials is to have printed circuit board materials, the substrate themselves, that are actually thermally conductive. And that allows you to spread the heat in the X and Y direction, but also to conduct the heat through the board in the Z direction.
Right.
Overall, that helps you to keep the junction temperatures, the peak junction temperatures cooler, and that increases your reliability for the board, so you have a longer board life.
Which markets are you targeting at?
So we see a lot of opportunity in the automotive market, and that's driven by a couple of trends. One is that HEVs and EVs are becoming a significant portion of that market. So this is the electrification of the market. And there's a couple applications within those. DC to DC converters is one, onboard chargers is another. Also in the automotive market, engine control units are becoming more dense. So this is, you know, essentially computer systems and power control units that are under the hood that have very stringent thermal management techniques or requirements. And, you know, you have to keep the size of the boards down and the weight down. That's critical for automotive. The second segment is very commonly known, it's LEDs, and that's becoming more popular in automotive, but also in the industrial commercial side. And finally, consumer electronics. This is like handhelds and wearables, and these devices need to be stay at a temperature of 37 degrees, the same as your body temperature, or maybe just slightly above at 40 degrees. And the size of the devices really dictates the thermal management. I mean, it's very small. There's really not a whole lot of extra thermal management techniques that you can use. And so we think that the printed circuit board high thermal conductivity solution might be a good solution there.
That's a lot of technical information. If you want, if readers would like to know more about your solutions, how would they contact you guys? Yeah,
so I'd suggest stopping online at our technical support hub, and it's rogerscorp.com/techhub, TECHUB.
All right.
And there we have really a repository for white papers, articles, videos, and we have training that's right there on the Tech Hub. And if you have even more interest, you can always, through the Tech Hub, contact your local sales engineer, and we'll contact you and answer your questions for you.
All right. John, what can you say about the show so far?
It's been really great. We've got great traffic, and it's been a really interesting and good experience.
And China is a big market for Rogers, so what can you say about, you know, the developments happening in the region from your perspective?
Yeah, from our perspective, things change and grow very rapidly in China. And of course, a lot of the manufacturing is being done in China. Rogers has a pretty large presence in terms of both in terms of manufacturing, but also in terms of sales and marketing and technical support in China. You know, but what we see is very, very rapid innovation. These markets that I mentioned before, like the automotive market, the LED, consumer electronics, a lot of that development is being done here in China.
Final words on your outlook for next year?
Things are looking very good. You know, you know, I feel like we're well positioned in the right markets, and you know, we're just waiting for, you know, for example, in the 5G, we're waiting for things to move into that area.
All right. Thank you very much, John, for joining me today.
Thank you. Appreciate it.
That's John Ranieri from Rogers Corporation. And I'm Stephen Las Marias for Real Time with HKPCA and IPC Show 2016. Thanks for watching.